All right, let's dive right in. Today, we're going to pop the hood on something that might seem really complex: programming. You might think it's some kind of dark art, right? Like magic. But really, it's not. By the time we're done here, you're going to see it's way more like having a toolbox full of really simple but super powerful tools.
So, here's the fundamental challenge, right? You've got this computer. It's an absolute beast. It can do millions of things a second, but it has zero common sense. None. So how do you command it? How do you get it to do exactly what you want? Well, that's what programming is all about. It's the language we use to talk to that brilliant but very literal assistant. It's really just the art of giving a computer a set of super specific commands so it can do its job.
You know what? Let's stick with that toolbox idea. I really like it. Think about it. You wouldn't grab a hammer if you need to cut a board in half, would you? Of course not. It's the exact same thing in programming. Every concept is a tool with a specific job. The whole trick is just knowing which tool to pull out of the box. So, let's open it up and see what's inside.
Okay, tool number one. This is the big one, the absolute foundation of everything else we're going to talk about. Sequential instructions. It's exactly what it sounds like. The computer just does things one after another in the exact order you tell it to. No skipping ahead, no getting creative.
It's literally like following a recipe. Look at this. Step 1, print hello there. The computer does that. Then, and only then, does it move on to step 2, print the result of 6 plus 5. It does the math, gets 11, and prints it. It just goes down the list one by one. Super simple, right?
Okay, that's great for simple lists. But what happens when things get more complicated? What if you need your program to be, well, a little smarter? What if it needs to react differently depending on the situation? A straight line isn't going to cut it anymore. And that's where we need our second tool: making decisions. This is what we call branching. Just picture a fork in the road. The program gets to this fork and has to make a choice. It asks a question like, if j is greater than 10? If the answer is yes, boom, it takes one path. But if the answer is no, that's the else part, it's forced to take the other path. It's this simple if this, then that logic that lets a program actually seem intelligent and adaptive.
All right, so we can go in a straight line and we can make choices at a fork in the road. But what about those annoying repetitive tasks? You know, the stuff you have to do over and over again. I mean, nobody wants to write the same line of code 100 times. That's just painful. We need a better way. We need a tool for repetition.
Okay, let's say you want to make a multiplication table for the number 12. You could do it the hard way. Line 1, print 1 times 12. Line 2, print 2 times 12. Line 3, you see where this is going, all the way to 12. Yeah, it would work, but man, what a slog. And you'd probably make a typo somewhere. It's just not a smart way to work. And this is where our third tool comes in to save the day. It's called a loop, and it is an absolute game changer. A loop basically tells the computer, hey, see this little bit of code? I want you to do it again and again. So instead of those 12 long, boring lines for our multiplication table, we can write one tiny, elegant loop that does the exact same thing. It's amazing.
And bam! Look at that! A perfect multiplication table done in an instant. The loop just cruised through the numbers 1 to 12, did the math for each one, and spit out the answer. That is the power of automation right there. Think of all the time and headache we just saved.
So, we've got our 3 main tools now. But you might be thinking, okay, that's cool, but how do we get from printing a multiplication table to, building a whole app? That's a great question. Let's connect the dots.
So let's recap the whole toolbox. We have sequential instructions to do things in order, we have branches to make decisions, and we have loops to handle repetition. That's it! It might sound way too simple, but I promise you, these 3 concepts, they're the Lego bricks that build basically all software.
Seriously, think about it. The app you use to order food, the website you're on right now, even the most complex video games, they are all, at their core, just a massive, intricate combination of these 3 simple ideas. That's the secret sauce. These tools are so powerful because they're based on the same kind of logic we use to think every single day. So now, you've seen what's inside the toolbox. You know the basics. The only real question left is, what are you going to build with them? See, programming isn't some secret club or some kind of magic. It's a creative skill. It's about problem solving. And it all starts right here with these 3 simple but incredibly powerful tools.